All right, drawing out Lewis dot structures. So one way to draw out Lewis dot structures, like for the molecule nitrogen, N2, is to consider each atom before it's formed any bonds. Now here we have nitrogen. Each nitrogen has only 5 valence electrons initially. You know this because it's in group 5A. And so we can draw 5 dots around each nitrogen. But you see, each nitrogen, in order to be more stable, will need a filled valence shell. And for most atoms, like nitrogen, it will need a full octet. It will need 8 valence electrons. And so you see that it has 5 valence electrons, but it needs 8. It needs 3 more. Now it could gain 3 more by having 3 electrons given to it from a metal, which would form an ionic compound, or instead it can share electrons with another nonmetal, such as another nitrogen. So you see that this nitrogen needs 3 more electrons, and so this nitrogen could send 3 electrons over to it. Similarly, this nitrogen needs 3 more electrons. It has 5. So this nitrogen can send 3 more electrons over to it. And so the molecule N2 actually has 2 nitrogens with now a total of 3 plus 3, or 6 electrons being shared in between the 2 atoms. And as well, there are 2 electrons on the outside for each. Now, you can see that each nitrogen now has 2, 4, 6, 8 valence electrons around it. This is the case for both nitrogens. You see that these electrons can now belong to the valence shells of both nitrogens. They're being shared in a covalent bond. You can represent a covalent bond by using lines. Now, here we have 3 pairs of electrons, and so we'll use 3 lines between the nitrogens. Each pair of electrons gets 1 line. So having 3 pairs, we get 3 lines. This is a triple bond. So this is one way to draw out Lewis dot structures. However, another way is a little bit more systematic, and ultimately, once you figure it out, should save you time. And so let's give it a shot. There's really essentially 3 steps. Trying to draw nitrogen again, we're going to make a happy structure. We're going to remove electrons, because in our happy structure we'll have too many electrons, more than we can have. And then we'll need to move electrons to give everyone a full octet. So our first objective is to make our happy structure. This involves our atoms being held together by just single covalent bonds initially. And then we add on enough electrons to give everyone a full octet. You can see the full list of instructions written out in our homework assignment, but I've only written these 3 things. We give everyone a full octet if they need them, except for hydrogen, of course. And this gives us our happy structure. And now, we need to remove a certain number of electrons. To know how many electrons need to be removed, we need to first compare how many are going to be in this needed structure, in our happy structure, how many are needed in our happy structure. And then we'll find a difference between that and the number of electrons that will actually be available, which will be from the valence shells of each nitrogen initially, before they've formed any bonds. So how many electrons are needed for our happy structure? How many electrons are in this happy structure? You see 2, 4, 6, 8, 10, 12, 14. There are 14 electrons in this happy structure. This includes the 2 electrons in this bond. And now we need to determine how many electrons will actually only be available. You'd seen previously that each of these nitrogens brought 5 valence electrons. Ultimately, we should have a total of 10 valence electrons, as you saw in our final product. Now, another way to calculate the number of available electrons is to say, hey, there are 2 nitrogen atoms. Each one brings 5 valence electrons, so multiply 2 times 5. A total of 10 electrons will be available from the valence shells of these nitrogens. So right now we have 14 valence electrons. However, we only get to have 10. And so we need to remove the difference, remove 4 electrons. Now we're going to remove these 4 electrons. You can do this from really any of these nitrogens, but let's arbitrarily set to remove them from the left one. And now we can draw in for the moving stage. We just removed electrons. Now we need to move electrons to make everyone happy, to have them all have filled valence shells, full octets. So let's see, this nitrogen, is it happy? Does it have a full octet? Well, it has 2, 4, 6, 8 valence electrons. It is stable. Is this nitrogen stable? Well, no. It has 2, 4 valence electrons. It needs more, 4 more, to have a filled octet. And so we'll move a total of 4 electrons in to form a bond towards that nitrogen. In that way, both nitrogens will have 8 valence electrons around them. And so when you draw this final compound, it's important that you draw now 1, 2, 3 bonds, and only the electrons which have not been moved. It's important that when you move these 2 electrons and these 2 electrons, you're erasing them. So you should get this final structure, which is the same one that we'd seen from our initial technique. Let's check our answer. Let's see. Check. Number 1, do we have the proper number of valence electrons? I.e., do we have that same number of available electrons? 10. Well, you see that you do. Here, there's 2, 4, 6, 8, 10 valence electrons. Additionally, do we have filled valence shells? Does everyone that needs an octet have it? Yes, this nitrogen has 2, 4, 6, 8 around it. And this nitrogen also has 8 around it. And so we have a full octet. We can also follow the same procedure for carbon dioxide. So, draw first a happy structure. So, put carbon in the center. It's the least electronegative of them, so it goes in the center. And then you put oxygen on the outside. And now you can draw enough electrons on these guys to give them full octets if they need them. So draw 6 more electrons on oxygen. Now it has 6 plus 2, it has 8 valence electrons. Carbon, draw 4 more. Oxygen, draw 6 more. So this is our happy structure. How many electrons are needed in this happy structure? How many are in the happy structure? Well, count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's 20 electrons needed for our happy structure. However, this is not the number of electrons that will be available. You see, each carbon brings only 4 valence electrons from its valence shell. You know this because it's in group 4A. A total of 4 electrons, valence electrons, are coming from carbon. Now, there's 2 oxygen. Each one brings 6. There's a total of 12 electrons coming from oxygen. And so there's a total of 4 plus 12. There's a total of 16 electrons available to us. Now, right now there's 20 electrons here, but we only get to have 16, so we need to erase 4. We need to remove 4 electrons. And so erase 4. You might arbitrarily remove them from carbon. And now we need to complete step number 3, move electrons, until everyone has a full octet, or at least a filled valence shell if they're hydrogen. So oxygen is happy. It currently has 2, 4, 6, 8 valence electrons. But carbon is not happy or stable. It only has 4 valence electrons. Move 4 more valence electrons in towards it. And when you do that, you'll be forming new bonds. Be sure to erase those electrons which you just moved. Do we have the proper number of valence electrons? Yes. Do we have the filled valence shells, full octets for everyone? Yes. You're done. Thanks for watching, guys.